Yes. Okay. Now let's see. Again, I have to explain. Uh, this is the ideal solution, students. This is the non-ideal solution. In case of ideal solution, delta V mixing is 0. Non-ideal, it's a positive deviation. It's a negative deviation. One is positive deviation. Second one is negative deviation. What will happen in the negative deviation? The bond strength of AA and BB is weaker than the bond strength of AB. जो बच्चों नया बॉन्ड बनेगा वो नेगेटिव डेविएशन में स्ट्रॉन्ग बॉन्ड बनता है. जो पॉजिटिव डेविएशन होता है वहां पे जो नया बॉन्ड होता है वो वीक बनता है. एंड इन केस ऑफ आइडियल सॉल्यूशन जो नया बॉन्ड बनता है वो जो पुराने बॉन्ड होते हैं उन्हीं के सेम स्ट्रेंथ का होता है. गॉट इट? दैट्स व्हाई if suppose I am taking the 10 ml of this one, 10 ml of this one, and I mix this one, 20 ml of AB will form exactly. How it's exactly 20 ml will form? Because the bond strength of AA and BB are equal to AB. So there is no change in volume. That's why 20 ml of volume will form. यहाँ पे देखते हैं. Here the new bond. This is the new bond, student. This is the new bond, and new bond is weaker. New bond is weaker. ये weak bond होता है. इस weak bond के लिए क्या करना होगा? जो नया bond होगा ये weak bond होगा. weak bond होगा तो bond length ज्यादा होगी. bond length ज्यादा होगी तो volume भी ज्यादा होगा. If suppose this is the weak bond, then it means bond length will be more. Bond length will be more, then volume will be more. Next, and volume will be more. That's why delta V mixing will be positive. And second point, delta V mixing is equal to negative. Negative means the new bond is strong bond. New bond is strong bond. Suppose this is the 10 ml and this is the 10 ml, and I mix the 10 ml and 10 ml. This become the less than 20 ml because the bond is strong. Strong bond is bond length is less. Less bond length means volume is less. Volume is less. तो ये बॉन्ड लेंथ लेस होती है तो वॉल्यूम भी लेस हो जाएगा. तो 2020 लेस देन 20 ml हो जाएगा. तो ये वाला पॉइंट भी वी हैव कवर्ड. गॉट इट? नेक्स्ट पॉइंट चलते हैं बच्चों. अच्छे से समझना. आई विल एक्सप्लेन ईच एंड एवरीथिंग. नाउ इन केस ऑफ आइडियल सॉल्यूशन, in case of delta H of mixing, delta H of mixing is equal to 0. Delta H of mixing is equal to 0. In case of non-ideal, in case of non-ideal, here is the positive deviation and here is the negative deviation. यहाँ पे पॉजिटिव डेविएशन है, यहाँ पे नेगेटिव डेविएशन है बच्चे. तो अब यहाँ पे क्या होगा? यहाँ पे तो मैंने मेंशन कर दिया. आई मेंशन हियर डेल्टा एच ऑफ मिक्सिंग इज इक्वल टू 0 एंड व्हाट आई हैव टू मेंशन हियर डेल्टा एच ऑफ मिक्सिंग इज इक्वल टू कैसा होता है बच्चों? पॉजिटिव की नेगेटिव? चैट बॉक्स में बताओ क्या होना चाहिए. एंड व्हाट वुड बी द रीजन why delta H mixing here must be positive और negative? उसका आपको रीजन भी पुट करना पड़ेगा. तो और यहाँ पे कैसा आएगा चैट बॉक्स में? कोई भी anybody else? delta H of mixing here is equal to कैसा हो जाएगा? delta H of mixing यहाँ पे नेगेटिव आ जाएगा. यहाँ पे चैट बॉक्स में किसी ने मेंशन नहीं किया. यहाँ पे पॉजिटिव आ जाएगा. अब देखो ये पॉजिटिव नेगेटिव कैसे आते हैं. पॉजिटिव नेगेटिव कैसे आते हैं उसको मेंशन करते हैं. ए का बॉन्ड और बी का बॉन्ड ये सेम स्ट्रेंथ के हैं ए बी के बॉन्ड से. The bond strength of AA and bond strength of BB is similar to the new bond strength AB. Now, if suppose 10 kilojoule energy required to break down this bond. Got it? Per mole. Then the bond strength is same. 10 kilojoule energy will release when the new bond will form. It means the entire energy will compensate by the new bond. 10 kilojoule energy required to break a bond, and the bond strength, new bond form, and that is of similar bond strength, and 10 kilojoule energy is released when new bond is formed. The delta H becomes the 0. Here, what will happen? Here, AA bond strength or BB bond strength is greater than AB bond strength. That means here 12 kilojoule energy required, suppose, per mole. But the new bond is weaker bond. Might be it release the 10 kilojoule energy. Overall energy is consumed. If energy is consumed, then delta H mixing will be positive. Hope you got it. Here, new bond is strong bond. New bond is strong bond. If suppose a strong bond is there, to break this bond, I need 10 kilojoule per mole energy. But the strong bond release 12 kilojoule per mole energy. It indicates overall energy is released, or when overall energy is released, we can say the delta H of mixing is negative. Hope you got it. I not understand Hindi. Explain in English. I am explaining only in English. I am using very less word of Hindi because there are few students, some students are of from English medium, Hindi medium also. That's why I'm using little bit Hindi also. Got it? And EMRS Langalai. Okay, I'm trying my best to explain in English also, dear. Further, if you need more English, then I can use it. Okay. Then I have explained this one. Delta H of mixing is equal to 0. Delta H of mixing is positive. Delta H of mixing is negative. Got it, my dear? Then next point. Here delta S. What is delta S? What is delta S? Can anybody tell me? What is delta S? It's an entropy. It's a entropy. Entropy means degree of randomness. Degree of randomness. And delta S will be positive. Think, if you mix two solutions, or if you mix two class 11th and class 12th, there is a increase in randomness or decrease in randomness? Obviously, it is an increase in randomness. Whenever two solution is mixed, the entropy of the solution always will increase. And here also delta S also will be positive. Delta S also will be positive. It doesn't matter whether solution is ideal, non-ideal. In non-ideal, it's a positive deviation or negative deviation. It doesn't matter. Because we are mixing the two solution. Two solution means here only the AA bond is there. Here only the BB bond is there. And now if I'm mixing here, new bond, AB bond, AA bond, BB bond is there. So there is a more degree of randomness. More degree of randomness means delta S will be positive in all three cases. Next point. Next point is delta Z. Delta G is equal to will be negative. What is delta G? Can anybody tells me? Can anybody and can anybody mention in the chat box what is delta G? What is delta Z? I'm waiting for the answer. If someone give me what is the exact definition of the Gibbs energy? Yeah, what is exactly Gibbs energy? What you understand by the Gibbs energy? You heard so many times what is Gibbs energy. So let me explain. I didn't get any response. Delta G is equal to Gibbs energy. Gibbs energy. And what is exactly Gibbs energy? Maximum energy that can be converted into work. Maximum energy that can be converted into work. For example, if suppose I stay in the Ghaziabad and someone say me, sir, you have run from Ghaziabad to Delhi. Then I say, okay, I will run. I start my journey from Ghaziabad and I have the target to run till Delhi. Now, what will happen when I reach? When I reach this position, I becomes very tired. I become very tired. I become very tired. And now this place onwards, I say, no, I can not run more. So that means it doesn't means I don't have the energy. It means I have the energy, but I cannot convert into the work. So the energy I convert from the energy I use from here to here, the energy that I convert into the work, that is called Gibbs energy. I suppose you say me, sir, you have to do some like push up like that. Then I made 100 push up, and in 100 push up, whatever I energy lost, this is called Gibbs energy. जिस एनर्जी को मैं वर्क में कन्वर्ट कर सकता हूं, उसी एनर्जी को हम गिब्स एनर्जी बोलते हैं। और जिस एनर्जी को मैं वर्क में कन्वर्ट नहीं कर सकता, इसलिए हम उसको गिब्स एनर्जी नहीं बोलते। अर्लियर बिफोर 2004 there was a convention, we called this Gibbs energy is a Gibbs free energy. Gibbs free energy. But 2004 onwards, the IUPAC said we cannot say it's a free energy, not free energy, because earlier it was understood that it's a free energy that can be converted into work. But now IUPAC recommend that you cannot say it's a free energy, you have to say only the Gibbs energy. One more thing, Gibbs energy delta G is equal to negative for spontaneous reaction. For spontaneous reaction, delta G is equal to 0 for at equilibrium. Delta G is equal to positive for non-spontaneous reaction. Non-spontaneous reaction. Delta G negative hoga for spontaneous reaction. If delta G 0, that we can say the reaction is at equilibrium. If delta G positive, we can say it's a non-spontaneous reaction. For ideal solution, delta G is equal to negative. For non-ideal solution, for positive deviation and negative deviation, delta G also negative. Delta G also negative. Try to understand this one also. If suppose I am mixing two solutions. If suppose I mix milk and water. If suppose I mix alcohol and water. Is there any energy required to mix? No. Once I mix both the solution, they mix automatically. That means it's a spontaneous reaction. It's a spontaneous reaction means delta G would be negative. No issue at all. Now, most important now about the ideal and not ideal solution. They will ask you, they will give you the pair. Predict, yeah, tell us whether this pair N-hexane plus N-butane, it shows ideal is it a solution of ideal solution, non-ideal solution? If non-ideal solution, then tell us whether it show positive deviation or negative deviation. So I'm telling you the few techniques on the basis of you can predict whether the pair is ideal solution or non-ideal solution, or in case of non-ideal solution, whether it show positive deviation or negative deviation. Let's see, if the pair has the difference of only CH2, the solution will be ideal solution. For example, this is benzene, and if I mix the solution of benzene with toluene, both has the difference of CH2. It means it is a pair of ideal solution. N-hexane and butane, it does not have the difference of CH2. So it's not an ideal solution. It's not a ideal solution because here is the difference is more than CH2. But if I write here N-hexane and N-heptane, then in between N-hexane and N-heptane, there is a difference of CH2. That's why it make a pair of ideal solution. ये भी एक ideal solution का pair बनाता है बच्चे. Second point, if there is a difference of one halogen, if difference is of one halogen, अगर एक हेलोजन का डिफरेंस है तो भी ये क्या बनाएगा बच्चों, एक आइडियल सॉल्यूशन बनाएगा. कैसे? लेट्स सी, it's a chlorobenzene and it's a bromobenzene. After chlorine there is a bromine, so it pair will form the ideal solution. If there is a iodobenzene, then the pair of this one is ideal, but this one and this one is non-ideal. If there is a difference of successive halogen means If suppose chlorobenzene, then it form the pair of ideal solution. If fluorobenzene and bromobenzene, now the difference is 2, it will not form the ideal solution. So difference is of one halogen. One halogen matlab means successive halogen. ये आपको देखना है. Now delta Z is equal to negative. Delta Z is equal to अच्छा negative. Here the in case of positive deviation, how I predict the it's a positive deviation or it's a pair of negative deviation. Let's see. If there is a hydrogen bonding in one compound, for example, whenever water is there, anything else, whenever C2H5OH is there, hydrogen bonding is there, anything else is there, it will form the positive deviation. It will create the positive deviation. Let's understand with the negative deviation. If there is a pyridine, aniline, strong acid, strong base, weak acid, weak base, if anything found uh, in any pair, blindly you can say it's a negative deviation. Blindly you can say it's a negative deviation. One more thing, in negative deviation, it's a AB bond is stronger. It means the pair must be, if both are polar plus polar, they will interact with each other and they will form the negative deviation. If non-polar, that means they will interact with each other and they form the negative deviation. If polar plus non-polar, that means polar does not dissolve in the non-polar. So that means it's a positive deviation. It's a positive deviation. So on the basis of these points I have told you, they are not mentioned in any book, any textbook. You can predict whether the pair will show positive deviation or negative deviation. I am putting some few examples. On the basis of that, you predict whether this pair show the positive deviation or negative deviation. Let me check few pair from NCERT. Okay. Positive deviation or show me. H2O plus C2H5OH कौन सा डेविएशन शो करेगा? CCl4 प्लस CHCl3 कौन सा डेविएशन शो करेगा? I told you, this show the hydrogen bonding, this also show the hydrogen bonding. हाँ जी, मैं हिंदी में भी एक्सप्लेन कर देता हूँ। ये भी हाइड्रोजन बॉन्डिंग शो करेगा, ये भी हाइड्रोजन बॉन्डिंग शो करेगा। तो आई टोल्ड यू कि पेयर में से एनी any compound show the hydrogen bonding, it will show the positive deviation. Very good. Varalakshmi, very good. First one is positive. Second one, how you will predict? Second one को बताओ बच्चों, ये पॉजिटिव शो करेगा या नेगेटिव शो करेगा? देखो, ये पोलर है कि नॉन पोलर है? दिस वन इज नॉन पोलर, गॉट इट? एंड दिस वन इज पोलर। पोलर नॉन पोलर, पोलर पोलर के साथ मिक्स होगा, नॉन पोलर नॉन पोलर के साथ मिक्स होगा। पोलर विल बी मिक्स विद द पोलर, नॉन पोलर मिक्स विद द नॉन पोलर। देन it means I told you in the last slide, polar नॉन पोलर क्या शो करेंगे? पॉजिटिव डेविएशन। तो ये भी कौन सा पेयर शो करेगा? पॉजिटिव डेविएशन। गॉट इट? आई एम पुटिंग few more example. H2O plus HNO3. Tell me. Tell me which one show. I'm coming back within 1 second. I have to take some glass of water. It will shows negative deviation. Very good. I told you it's a strong acid. It's a strong acid. That's why it will show negative deviation. One more. CH3OH plus CH3COOH. Tell me this one. CH3 CO CH3 CHCl3. Tell me. Tell me, student. What will it shows? It's a 1. You have told me 2 and 3. You can say, sir, second one will shows. Varalakshmi, negative. Very good. It's a negative deviation. It's a weak acid. Now this one, third one. Third one is negative. How? How this one is a negative deviation? See, this is polar or non-polar? It's a polar. And this one is also a polar. When polar mix, तो जो पोलर मिक्स हो जाते हैं, राजेश खान सर, तो अभी मैंने आपको बताया था मैं क्या करता हूँ सर, क्योंकि इट्स डिफिकल्ट टास्क होती है हिंदी और इंग्लिश दोनों, तो मैं एक लाइन हिंदी की एक लाइन इंग्लिश की बोलता हूँ। तो प्लीज try to understand each and everyone. I want to satisfy each and every student. It is polar, it is polar. तो दोनों ही पोलर हो जाते हैं। तो पोलर पोलर के केस में क्या बताया था बच्चों मैंने? पोलर प्लस पोलर नेगेटिव डेविएशन। सो हम कह सकते हैं वी कैन से कि इट्स ए नेगेटिव डेविएशन। रेडी मी 9, it's not a positive deviation बेटा, it's a negative deviation. होप अब बच्चों जो मैंने आपको टेक्निक सिखाई, what I teach you the technique to find out whether the pair is shows the positive deviation and negative deviation. This technique is very important in board exam also. बच्चों जो मैंने आपको सिखाया ये पॉजिटिव डेविएशन और नेगेटिव डेविएशन को फाइंड आउट करने का, ये टेक्निक बहुत ही ज्यादा महत्वपूर्ण होने वाली है आपके बोर्ड एग्जाम के लिए भी और आपके नीट और जेई एग्जाम के लिए भी। नेक्स्ट टॉपिक पे मूव करते हैं अब हम बच्चों। नेक्स्ट टॉपिक आ जाता है आपका एजियोट्रोप्स। बच्चों समझने की कोशिश करना इसको भी, ट्राई टू अंडरस्टैंड दिस कंसेप्ट आल्सो वेरी वेरी क्लियरली। Don't try to mug up the things. Try to understand the concept. What is exactly first azeotrope? क्या होता है? Suppose I am telling you few things before explaining the azeotrope. तो आपको कुछ आइडिया आ जाएगा। One container, it's a water. Sorry, it's a what? And it's a layman concept. I am telling you it's a layman concept. पर आपको समझ आ जाएगा इससे। मतलब बहुत अच्छा जो मैं यहाँ पे चीजें मोल्ड करूंगा वो कंप्लीटली उसको सेटिस्फाई नहीं करती। इट डजंट सेटिस्फाई कंप्लीटली, बट इट इज द वे टू लर्न द थिंग ओनली। इट्स अ वाटर एंड इसका बॉइलिंग पॉइंट होता है 100 डिग्री सेंटीग्रेड। इसका जो वाष्पांक होता है, जो बॉइलिंग पॉइंट होता है वो 100 डिग्री सेंटीग्रेड। If suppose I mix this one in acetone, obviously इसका जो boiling point होगा वो less than 100 ही होगा। And I don't know कि किसका मेरे को boiling point सभी के याद रहे। मैं assume कर लेता हूँ suppose this one is the 40 डिग्री सेंटीग्रेड। ठीक है। अब now I mix two solution. I mix two solution, दोनों solution को मैं mix कर देता हूँ। दोनों सॉल्यूशन को मिक्स करने पे और दोनों की क्वांटिटी 50-50% ले लेता हूं। तो मेरे को बताओ बच्चों किसका वेपर प्रेशर ज्यादा होगा? वाटर का या एसीटोन का? कोई भी बच्चा बताओ किसका वेपर प्रेशर ज्यादा होगा? यहाँ पे किसकी वेपर ज्यादा बनेंगी? और मैं इनको सपोज करो 80 डिग्री सेंटीग्रेड पे, या 80 नहीं लेते, 30 डिग्री सेंटीग्रेड पे इसको बॉईल करता हूँ, मतलब बॉइलिंग हीट देता हूँ। तो किसकी वेपर ज्यादा बनेंगी? वाटर की सर वाटर का बॉइलिंग पॉइंट ही 100 डिग्री सेंटीग्रेड मेंशन किया है मैंने, वारा लक्ष्मी जी। If I mention the 100 degree centigrade, that means its boiling point is higher. It's you student know the definition of boiling point. Can anybody mention me? Because you people have the Google Baba. तो गूगल बाबा से तो आप फिर सर्च करके बताते हैं। तो व्हाट इज बॉइलिंग पॉइंट? It is the temperature at which boiling point of अरे सॉरी क्या लिख रहा हूं मैं भी। It is the temperature at which vapor pressure of liquid equal to atmospheric pressure। ठीक है। हाँ, एसीटोन की वेपर वहां पे ज्यादा बनेंगे। बहुत अच्छे बच्चे। देखो, मैं एक कंटेनर लिया, इसको हीट करता हूं। हीट करने पे यहाँ पे एक फ्रिक्शन लेस वो रख देता हूँ। ये ऊपर से प्रेशर लगाएगा, इसकी वेपर यहाँ से प्रेशर लगाएंगी, तो ये फ्रिक्शन लेस है। फ्रिक्शन लेस है। तो ऐसा प्रेशर, ऐसा टेम्परेचर जिसपे इसका वेपर प्रेशर ऊपर के एटमॉस्फेरिक प्रेशर के इक्वल हो जाए, हम उसको बॉइलिंग पॉइंट बोलते हैं। तो यहाँ पे वाटर का बॉइलिंग पॉइंट ज्यादा है, उसकी वेपर्स कम बनेंगी। तो यहाँ पे जो वेपर्स, मोर वेपर एसीटोन। ठीक है। बच्चों ये सब मैं आपको एजियोट्रोपिक समझाने के लिए कर रहा हूँ कि वो आपको अच्छे से समझ आ जाए कि एग्जैक्टली होता क्या है। अदरवाइज एजियोट्रोपिक का एक लाइन में डेफिनेशन होता है, मैं उसको क्लियर करता आगे मूव कर जाता। तो मेक पेशेंस और ट्राई टू अंडरस्टैंड द कंसेप्ट। अगर मैं दूसरी बात ये बोलता, सपोज अनदर पॉइंट इज लाइक दैट, कंटेनर है आपका 80% वाटर है और 20% एसीटोन है। अब किसका वेपर प्रेशर ज्यादा होता या किसकी वेपर ज्यादा बनती? नाउ विच constituent compound form more vapor pressure? Now listen me carefully. It's a difficult to find out which one has more vapor pressure, because water has more boiling point, its vapor pressure will be less, but its quantity is more. Quantity is more on the surface of the liquid, more particle of water is there. So there is a high chances that water molecule will evaporate and less chances that acetone particle will evaporate. क्योंकि सरफेस एरिया पे ज्यादा वाटर के मॉलिक्यूल है, वो उसकी प्रोबेबिलिटी बढ़ा देता है कि वाटर का वेपर प्रेशर ज्यादा हो। बट वाटर का बॉइलिंग पॉइंट ज्यादा है, तो ये उसकी प्रोबेबिलिटी को डिक्रीज कर देता है कि उसका वेपर प्रेशर ज्यादा हो। एसीटोन का वेपर बॉइलिंग पॉइंट कम है, द वेपर प्रेशर ऑफ एसीटोन इज लेस, दैट्स व्हाई देयर इज अ हाई प्रोबेबिलिटी दैट एसीटोन का वेपर प्रेशर ज्यादा हो. तो इन सच ए केसेस I cannot predict. I cannot predict. Maybe both constitute the same vapor pressure. Water because of its quantity, acetone because of its less boiling point. तो ऐसा कोई मिक्सचर एजियोट्रोफ क्या होगा फिर? नाउ ट्राई टू अंडरस्टैंड एजियोट्रोफ. इट इज ए कंपोजिशन. इट इज ए composition. It is a composition of two or more liquids where both have same vapor pressure. Now hope you got it. मैंने एक ऐसा कंपोजिशन लिया है जहां पे दोनों का वेपर प्रेशर इक्वल टू सेम हो जाए. अब इसके देयर आर सो मेनी डेफिनेशन ऑफ एजियोट्रोपिक, बट ट्राई टू अंडरस्टैंड. इफ सपोज ये ए और बी का कोई कंपोजिशन है, इट इज ए कंपोजिशन ऑफ ए एंड बी, and now both have the same vapor pressure. Vapor pressure of A equal to pressure of B. Now I can say this is a azeotropic mixture. Another definition what I can say, it is a composition where the mole fraction in liquid state and mole fraction in vapor phase are same. Third definition, it is a mixture that cannot be separated by simple distillation. सारे एक ही बात बताते हैं. एवरीथिंग टेल मी वो द सेम थिंग. अगेन, अब सपोज दोनों का वेपर्स यहां से सेम निकलता है. इफ बोथ लिबरेट द सेम वेपर्स, then if I heat this one and I think that I can separate A from B because the vapor of A will be more, vapor of B will be less, and then I will collect this vapor here. So it will not happen na, because both vapors are liberating in the same amount. So mole fraction in liquid phase and mole fraction in gaseous state both are same. That means such kind of mixture are called azeotropic mixture. If suppose I withdraw a graph, I draw a graph, not withdraw, I draw a graph like that. XA is equal to 1, XB is equal to 0, XA is equal to 0, XB is equal to 1. Might be graph is like that. Got it? Think about this graph. Whenever I heat any liquid, the composition of A and B, there will be 2 mole fraction. 1 mole fraction in liquid state and 1 mole fraction in the vapor phase. So this is the composition in the liquid phase. Yeah, this is the mole fraction in liquid phase and this is the mole fraction in vapor phase. This is the mole fraction in vapor phase. Hope you got it. This is the mole fraction in liquid phase. This is the mole fraction in vapor phase. Now, again, come to the topic azeotropic. If I draw the graph, XA is equal to 1, एक्स बी इज इक्वल टू 0। एक्स ए और एक्स बी यहाँ पे 1 है, 1 है मीन्स ओनली यहाँ पे ए है। एक्स ए इज इक्वल टू 0, एक्स बी इज इक्वल टू 1। ये बच्चों वेपर फेज का कॉन्स्टिट्यूएंट है। ये लिक्विड फेज का कॉन्स्टिट्यूएंट है, कंपोजिशन है। इस कंपोजिशन पे आके दोनों वेपर फेज और लिक्विड फेज दोनों के दोनों फेज का मोल फ्रैक्शन सेम हो गया। यहाँ पे मोल फ्रैक्शन लिक्विड फेज में अलग है, और इस पॉइंट पे, किसी भी पॉइंट पे अगर मैं देखता हूं बच्चों, इस पॉइंट पे, इस कंपोजिशन पे, इस कंपोजिशन पे, on this composition the vapor phase in liquid, vapor phase in gaseous state, both are different. It means it's not an azeotropic composition, but at this composition the mole fraction in liquid phase and vapor phase both are same. That's why it is called azeotropic mixture. Now if suppose this I take the vapor pressure this side, so it's a maximum boiling point azeotrope or minimum boiling point azeotrope? It's a maximum boiling point azeotrope or minimum boiling point azeotrope? समझते हैं बच्चों। मैं पहले पॉजिटिव डेविएशन को आपको क्लियर करता हूं, शायद वहां पे रह गया था, इट लेफ्ट, डिडंट ड्रॉ द ग्राफ। यहाँ पे सपोज करो एक्स ए इज इक्वल टू 1, एक्स बी इज इक्वल टू 0, एक्स ए इज इक्वल टू 0, एक्स बी इज इक्वल टू 1। तो ये आई कैन ड्रॉ द ग्राफ ऑफ लाइक दैट। इफ सपोज बी का ड्रॉ करना हो तो मैं ये ड्रॉ कर दे सकता हूं। ये इसका कंपोजिशन है, ये इसका वेपर प्रेशर है एट द टाइम ए व्हेन बी इज इक्वल टू 0। तो वेपर प्रेशर ऑफ ए इज मैक्सिमम। एज आई मूविंग दिस साइड द composition, the quantity of A is reducing, A is reducing, and here A become the 0, so vapor pressure of A become the 0. Similarly here also it is the only vapor pressure due to B. As I move this direction, the quantity of B is reducing, and here B is equal to 0. So it become the vapor pressure of B become the 0. ये P टोटल आ जाएगा यहाँ पे, क्योंकि ये तो A को डिनोट कर रहा है, ये B को डिनोट कर रहा है, लेकिन टोटल के अंदर तो बहुत कॉन्स्टिट्यूट द वेपर प्रेशर। If suppose positive deviation is there, if suppose positive deviation is there, पॉजिटिव डेविएशन के अंदर क्या होता है, ए का बॉन्ड स्ट्रॉन्ग होता है ए बी के बॉन्ड से। इट मींस वीक बॉन्ड, वीक बॉन्ड मींस मोर वेपर प्रेशर। तो जो मेरा वेपर प्रेशर आएगा वो ऐसे आएगा, यहाँ पे ये इसको टच इसलिए करेगा बिकॉज इट इज द ओनली बी हियर, देयर इज नो इंटरेक्शन। यहाँ पे भी टच ए को इसलिए करेगा, इट इज द ए ओनली हियर। एंड इफ सपोज देयर इज अ नेगेटिव डेविएशन, तो ए बॉन्ड बी बॉन्ड इज वीकर देन ए बी बॉन्ड। ये बॉन्ड स्ट्रॉन्ग है, स्ट्रॉन्ग बॉन्ड इज देयर, मीन्स लेस वेपर प्रेशर इज देयर। तो मेरा जो ग्राफ है वो इस तरीके से आएगा। गॉट इट? नाउ सी हियर आल्सो, here vapor pressure is decreasing or increasing? Vapor pressure is decreasing because in both side vapor pressure is decreased. Vapor pressure is decreased, that means इसका बॉइलिंग पॉइंट इंक्रीज हुआ है या डिक्रीज? वेपर प्रेशर क्या हुआ है? डिक्रीज हुआ है सेम टेम्परेचर पे। मीन्स जो नया बॉन्ड आया है वो स्ट्रॉन्ग बॉन्ड आया है, तो दैट मीन्स इट्स ए नेगेटिव टू डेविएशन। जो ऐसा कोई एजियोट्रॉप होगा वो नेगेटिव डेविएशन शो करेगा। और अगर मैं ऐसा, और ये बॉइलिंग पॉइंट कैसा होगा? नेगेटिव डेविएशन मींस मैक्सिमम बॉइलिंग पॉइंट एजियोट्रॉप, मींस यहाँ पे बॉइलिंग पॉइंट इंक्रीज हो गया। और इफ सपोज ग्राफ इज लाइक दैट, here vapor pressure is increased, vapor pressure is increased, it means minimum boiling point azeotrope. या मैं बोल सकता हूँ न्यू बॉन्ड कैसा आएगा? वेपर प्रेशर इंक्रीज हो रहा है तो if vapor pressure is increasing, that means it's a positive deviation because new bond is weak bond, then only vapor pressure can increase. So I can say it's a positive deviation. Positive deviation. Now I'm putting some example. Whatever is mentioned in your NCERT. See, it says C2H5OH plus water and 96% of C2H5 and 4% of water, they form the minimum boiling point azeotrope. They form the, no, it's not minimum boiling point, it's a boiling point is 352 Kelvin. Its boiling point is 373, and if I mix this one, they form the 351 boiling point. So I can say it's a minimum boiling point azeotrope. It's a minimum boiling point azeotrope. And one more example, HNO3 plus H2O, they form the maximum boiling point azeotrope. The pair form the maximum boiling point azeotrope. And I think it's a 68% होता है, हाँ, it's a 68% HNO3 and 32% water. It's a maximum boiling point azeotrope, and it's a minimum boiling azeotrope. And you have to remember this one, bachcho, because it's mentioned in your NCERT. This pair is maximum boiling point azeotrope. This pair is minimum boiling point azeotrope. So hope I have complete the azeotrope. What is exactly azeotrope? If you want to study for board and mains exam, just understand only the what minimum boiling point azeotrope कौन सा deviation show करता है. Which one show maximum boiling point deviation? Maximum boiling point azeotrope. Maximum boiling point azeotrope के लिए कौन सा deviation mandatory है? So such kind of question will be in your mains and your board exam. Next topic we are going to cover This is colligative property. Colligative property. Those properties, those properties which depends upon the number of particles are called colligative property. जो प्रॉपर्टी नंबर ऑफ पार्टिकल पे, नंबर ऑफ कणों पे, कणों की संख्या पे डिपेंड करती है, उसको हम कोलिगेटिव प्रॉपर्टी बोलते हैं. लेट्स सी. फर्स्ट, रिलेटिव लॉवरिंग इन वेपर प्रेशर. बच्चों, वेपर प्रेशर इज नॉट ए colligative property. Lowering in vapor also not a colligative property. But relative lowering in vapor pressure is a colligative property. Try to understand this one always. Elevation in boiling point, क्वथनांक में बड़ा होना, lowering in freezing point, osmotic pressure. Osmotic pressure. These are four principles we will discuss in the concept of colligative property. These are the property which depends upon the number of particles. That's why they are called colligative property. And one by one, we are going to discuss each and every one. First, relative lowering in vapor pressure. Relative lowering in vapor pressure. इसको बोलते हैं हिंदी में कुछ जो वाष्प दाब में कुछ कमी होना. कैसे? P naught minus PS divided by P naught is equal to mole fraction of solute. Let's understand this one. Not like that the formula, I mentioned the formula and okay, that's done, sir. No. Always try to understand the concept. See, this is a pure liquid. this is a pure liquid, and this liquid create a pressure at a particular temperature. I can say the vapor pressure of this liquid is P naught. P naught means pure. Now, if I put some solute here, if I put some solute here, what will happen here? What will happen here? Some particle of solute come to the surface of wait a moment. हाँ जी, नमस्ते. अच्छा अच्छा अच्छा, ओके, थैंक यू. बिल्कुल, जी 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 जी. हाँ जी. If I put some solute here, then some particle of solute also there. And solute we understand is non-volatile. Non-volatile means जो solute होते हैं उनके particles क्या होंगे कि वो vapor phase में नहीं जाते. Means they are not volatile. They are not going to vapor. It means now vapor pressure of solution is means not now means vapor pressure of solution is less than vapor pressure of pure solvent. Vapor pressure of pure solvent. If I decrease P naught minus Ps, it means it is the lowering in vapor pressure. And if I divide this P naught minus Ps divided by P naught, it means it's a relative lowering in vapor pressure. Relative lowering in vapor pressure. Got it or not? Now, what we observed experimentally, the relative lowering in vapor pressure equal to mole fraction of solute. मीन्स रिलेटिव लॉवरिंग उतनी ही ज्यादा होगी जितना ज्यादा सोल्यूट का मोल फ्रैक्शन इस लिक्विड फेज में ज्यादा होगा. एंड on the basis of this equation, they ask so many questions in your exam. I am telling you the technique where they can trap you. So to come out from this trap, use such kind of technique, what I am telling you. First, P naught minus Ps divided by P naught is equal to mole fraction of solute. They will say an aqueous solution. They will say an aqueous solution. Aqueous solution means it's a P naught is equal to 760 mmHg. So they will not mention P naught. First thing. P naught minus Ps divided by P naught equal to N2 divided by N1 plus N2. Means, या मैं इसको 2 ना लिख के NB NA और NB लिख ले, मेंशन कर देता हूं. Now this concept is applicable for dilute solution. Applicable for dilute solution. So sometime in numerical, what I will do, I will neglect the value of NB. So P naught they have not given, they mention only the aqueous solution. So there is no need to go to the, okay, P naught is not given. PS I have to find out, or maybe given, is equal to NB divided by NA, because this concept is applicable for dilute solution. And in case of dilute solution, the mole of A and mole of B, that means mole of A is far greater than mole of B. That means I can neglect the mole of B here and I can put this simple formula. So on the basis of that, you can solve so many questions. In the last of chapter, I will discuss so many questions. Next topic. Next topic is elevation in boiling point. Elevation in boiling point. What happen in boiling point? See, if suppose this is the vapor pressure and this is the temperature. On x-axis, there is a temperature, and y-axis, there is a vapor pressure. If I plot a graph, the graph would be like that. I make more slope, so I have to like. If suppose this is a graph of solvent and I have to draw the graph of solution also, तो क्या करना पड़ेगा मुझे? इसके ऊपर या नीचे? तो ऑब्वियसली सॉल्यूशन का वेपर प्रेशर कम होता है, तो ये सॉल्यूशन का ग्राफ आ गया. सपोज this is the 1 atm here, vapor pressure. So when atmospheric pressure equal to vapor pressure, this is the boiling point of solvent, T1. This is the boiling point of solution, T2. What we have observed, delta TB is equal to T2 minus T1. And delta TB, we observed that directly proportional to the molality. जितना ज्यादा हम सोलवेंट के अंदर सोल्यूट डालेंगे, उतना ज्यादा इसका बॉइलिंग पॉइंट रेज होगा. मीन्स whatever be the greater the molality of the solution, greater will be the elevation in boiling point. Now, to remove this proportional constant, delta TB is equal to KBM, where KB is equal to molar elevation constant. Molar elevation constant. Got it? It is also called ebullioscopic constant. I can write this formula, delta TB is equal to KB, and molality is the mass of solute divided by molar mass of solute, mass by molar mass, moles आ गए, divided by mass of solvent into 1000. So this can be also formula. Now try to understand the nature of Kb. Kb is equal to mRTB square into 1000 into delta H of vaporization, where M denote the molar mass of solvent, TB denote boiling point of solvent, and delta H of vaporization means enthalpy of vaporization. Sometimes in JEE Advanced, first you have to calculate the Kb value from the given data. I suppose this one is not given, then Kb can also write RTB square divided by 1000 into latent heat of vaporization. So me also can find out the value of latent Kb with the help of latent heat of vaporization. So this is overall about the elevation in boiling point. Try to understand the graph. How on adding the amount of solute, it raise the elevation in boiling point, it raise the boiling point of the solution, and it solely depend upon the, not solely, it majorly depend upon the nature of Kb. Greater the value of Kb, greater will be the elevation in boiling point. And what we understand about the nature of Kb, तो ये हमारे को बताता है कि भाई देख उसका बॉइलिंग पॉइंट जितना ज्यादा होगा, Kb का वैल्यू उतना ज्यादा होगा, एंथैल्पी ऑफ वेपराइजेशन जितना कम होगा, Kb का वैल्यू उतना ज्यादा होगा. So now one more point I want to discuss with you people. Why I am studying this colligative property? What are the benefit of this colligative property? What are the benefit of this colligative property? तो सिग्निफिकेंस मैं आपको यहाँ पे 1 या 2 मिनट के अंदर एक्सप्लेन करता हूं. दिस इज द सिग्निफिकेंस. मेरे को ना व्हाट हैपन कि मेरे को एक ना डर्टी वाटर मिला है. डर्टी वाटर, और डर्टी वाटर मीन्स कोई एक कॉन्स्टिट्यूएंट इसमें मिला हुआ है. आई डोंट नो विच वन कॉन्स्टिट्यूएंट इज देयर. If someone asks me what is the molar mass of this compound that is mixed with this water, so with the help of colligative property, I can find out the molar mass of this dirt or this impurity. How? First, I can calculate experimentally the delta TB, elevation in boiling point. I know the nature of water, so I know the value of Kb also. Got it? The density of water is 1. If density exceed from the 1, that means its density is increased by that constituent atom. And on the basis of that constituent atom, that increase in density, I can find out the mass of that element or that compound that mix in this water. Again, listen carefully. The density of water is 1. If something is mixed in the water, its density will increase. That means difference in density. With the help of difference in density, I can calculate the mass. It dissolve in the particular amount of solvent. तो मैं यहाँ पे इसका मास भी कैलकुलेट कर सकता हूँ. मोलर मास आई डोंट नो, मल्टीप्लाई बाय मास ऑफ द सॉल्वेंट. वाटर का मेरे को सॉल्वेंट का मास भी मैं एक्सपेरिमेंटली अपने तरीके से ही लूंगा, एंड मल्टीप्लाई बाय 1000. So basically, these colligative property used to calculate the molar mass of the solute. Hope you got it. Okay, what is the significance of colligative property? In the next class, I will discuss depression in freezing point, osmotic pressure, and want of factor. After that, I will discuss some numerical that is relevant for the board exam, JEE mains exam, and few questions for advanced exam. Hope you enjoy the lecture. Thank you everyone for your positive support. Thank you.